The Apple Valley Model Railroad Club presents Modeling Basics 101. This six-part series introduces you to the exciting world of model railroading, covering everything from initial layout design to final scenery. For more information about the Apple Valley Model Railroad Club, visit their website at avmrc.com. Part 3, Wiring Workshop.
Today we're going to be talking about how to wire your model to the track, to get power to the track, and eventually being able to run our trains. So I have here with me Kevin, who's going to be helping us out today. He's going to be demonstrating how to solder the wire to the track and what needs to be. I think we've already shown here on the top of the model all of the tools that are necessary, and but without any other questionings right now, I'm going to turn this over to Kevin, let him begin talking about what we need to do.
Okay, I'm Kevin McGill. When I was in the Air Force, I had a class on high reliability soldering. It was a class that taught us to solder to NASA standards. But since we're not going to be sending something up into space, it's not going to be quite that critical. First off, let's talk about soldering irons. If you have one of these, throw it away. It is way too powerful for what you're going to be doing. Now, this is your typical pencil soldering iron that you will see that you can probably pick up at the hardware store. This, you don't have any control over what the temperature is. It's by guess and by God what temperature it is. You want something a little better. You've got one here that has an adjustable thermostat to it. That's what I'm going to be using here. You can also use a solder stand, a base station, but if you're working under a layout, that might be a little more difficult to get it operational underneath there. You have different kinds of solder. If you go to the hardware store and you pick up their solder and flux, it's going to be for plumbing. It is not for electronics. It's an acid-based flux that will eat the wires, and eventually it will cause you heartache and grief. What you're looking for is the electronic solder. It is a 60-40 mix or a 63-37 mix.
So you're saying that the flux is already in the solder. You don't want to buy
in the electronic
separately.
solder, it already has it the solder is wrapped around a rosin core, yes. And it does come in different diameters. This is a very fine solder. This is a little heavier. And when you're using it, you don't want to hold this whole thing. You want to take a piece and break it off and use it because you'll give you a lot more control. Let's see, what do we got in here? Wire strippers. We've got different kinds of wire strippers. These are pretty common where you can strip wire. This is my preferred type because it is adjustable to what you have, and as you get more experience with it, you can tell when you've gotten through the insulation and you're able to pull it off. This type, if you're going to be doing a lot of stripping, is very good. But when we get to the bottom of this, these are going to come in handy because we're not going to be working at the end. We're going to be working somewhere in the middle, and that will grab it and pull the insulation away. Let's see, then we will need to tin the wire. And what that does, you will strip the wire, then you will take and heat it up with your soldering iron and take a little bit of solder and put it on there, and you'll coat that solder, or coat the wire with that solder. What it does is it keeps the threads together so that if you're putting it in someplace, you're not having these extra wires sticking out someplace that's going to short something out. It also, when you're doing the soldering itself, that extra solder on there will help to get your
Attach
connection.
itself or connect it.
Yeah, get your connection proper or faster, because the track, or excuse me, the rails are plastic, so you want to get in and get out as fast as possible. Otherwise, you're going to end up melting your rails. Obvious.
So, Kevin, I have a question for you. You were talking about the wiring. You can actually have a solid piece of wire. Would you recommend tinning that?
Yes.
Even though it's just one, and then what I'm going to call strand wires, a lot of little thin wires that you kind of twist.
Yeah.
And then
stranded wire needs to be tinned as well.
Okay.
Yes. Let's see. Then we have that pretty much covers the basics of it. I have different versions of heat shrink tubing that come in handy when you're soldering, because you don't want that exposed metal out there just hanging in the breeze. Because sometimes it's a higher voltage. Maybe not here, but if you're someplace else, it can be. Electrical tape, it works fine, but over time, it starts to get gooey and basically loses its adhesive. So it comes apart on you. And let's face it, you have a layout, you're going to store stuff under it. And if you store something under it, you get enough under there, you might hit the wires, and okay, now you have a problem. If where you got 2 wires there, you might short them out. You don't really want to do that, because now you got to go troubleshooting again. Let's see, then we can use things, I've heard these referred to as Euro connectors, but I've always known them as Phoenix connectors. And they you'll screw those into the side, and they'll take that soldered wire, that tinned wire, and stick it in there and take your screwdriver and tighten it down on it. And that makes a good mechanical connection. Let's see, I think that's...
So with that, I just want to add, with this model that we're going to be using, those Euro connectors are already been attached. And I found out that with this type of pine wood, we attach them with these screws.
Sheetrock screws.
You need to pre-drill your hole. If not, you'll split the pine. So just make that mental note as we go.
Okay, so what we need to do next is we need to polish the rail, basically. We need to get any oxidation off of the rail, otherwise our solder is not going to stick as well. And then you can get things like a cold solder joint, which is not as good of a connection, and it will add resistance to the electricity, so from your source to your destination, it's going to be reduced. Voltage will drop over that connection.
So let me interrupt you, Kevin, here a minute. If you see on the layout, I have marked where I have already pre-drilled my holes for each wire drop that's going to go down in there. So I've made a note so that if you look above, you can see the holes it's already there. I used my regular 7/64 drill and drill those, so they are there. So one will be on one end and one will be on the other. So that has already been done.
Okay. So
the second thing is the little knob that holds the rail to the tie has been removed, and you may want to talk about how doing that.
taking out, if you look at the rails, you'll see that there is a little nub that actually holds the rail in place, and it's on each tie. And what you need to do is to get a X-Acto knife and be able to cut that off. Otherwise, it's going to interfere with the placement of your wire. That's
So wherever
simple there.
wherever you're going to put the wire, you need to
Just need to
do
take
one
off
side, not
one on the outside, because if you solder to the inside, obviously you're going to have a blockage there, and you're going to tear up your equipment as trying to get over it. But on the outside, just take out one of them. You don't need to take out several in a row, just one where you're bringing the wire up. And then I guess we're ready to run some of these wires. What I don't remember, was it red on the outside
Yes,
and black on the inside?
correct.
Okay. So what we would do is we'll thread this in here first if we can, just to help hold it in place. And we'll give this a bend. And then we'll take a pair of forceps and we will clamp that to the rail. Hold it in place, because if you don't hold it in place, you're going to get a cold solder joint because you can't hold it still well enough. One of the reasons you get a cold solder joint is because it moves while you're trying to solder it. And when the solder is cooling, that's when it's most critical. It needs to stay still.
Before you do that, I think, don't we have to rough up the rail?
We do.
So,
Yep, I missed that one. So I've got a Dremel tool here with a brush on it. I guess you could probably use a wire brush or something else, but just want to get the oxidation off.
and by doing that, Kevin, is that so that the solder will actually
Adhere better. Yeah.
adhere better? And do you need to do this side of the rail as well? Or
When you're
no?
doing that, you need to do it on each rail
Okay.
where you're going to be soldering to. So let's try this again. And my soldering iron.
Someone had mentioned to me something about putting some solder on the tip of your solder iron.
Oh, yes.
Why would you do that?
It helps with the heat transfer. Oh yes, that's another thing I wanted to look at. I had it here. I had a, well anyway. With using something like this, your solder station will come with a sponge. You use it when it's wet. That way, one, you're not tearing up your sponge, but two, it helps to get the garbage, the stuff off of your soldering iron that will inhibit sticking, the melting of the solder. You're wanting to run about 750 degrees Fahrenheit, which translates to roughly 400 degrees centigrade. My particular soldering iron here runs on centigrade, and I had to do that calculation.
Oh, very good.
It comes out to actually 398 and change, but I need to let my soldering iron here warm up a little bit before I try this.
So I'm going to ask, so when you're done basically soldering, you're using your wet sponge to kind of clean off your soldering tool. And then the next time you are going to solder, then you would have to put a little bit on that tip.
Usually you have, once your solder tip is tinned, because if you get a new soldering iron, you're going to have to season it, I guess would be the term to use. And as you can see, this one is pretty dirty. And that happens when you let it cool. Things oxidize on it. So as I heat it up, I will be cleaning it off here and then putting some solder on it so that we can then try and get this tinned here. Or excuse me, get it soldered in place.
So knowing that the residue or the goo that's on the soldering tool, would it be shiny or to show that there's nothing on there?
Yeah.
Okay.
Shiny is preferred.
Okay.
So we're going to have to heat our junction up, and then you put your solder right at the junction of where your solder iron is and your wire, your destination. And now we got that one in place. I can take this off. And if you have, you can run your finger across there, and if you have a little bit of a bump there, you can take your fine file and file it down, smooth it out so that it's not a bump that would inhibit or derail your engines. So there's our first one.
So what we're going to do now is we're going to complete the solder joints for that particular piece of track. We'll go to the opposite rail, and then we'll do the secondary track, which is on this side. And we're going to let you guys, as well as myself, try to solder on that. Once that is done, we're going to then flip the model over, and Kevin will talk to us about how we're going to do the rest of that. So we'll take a break here, and we'll be back shortly. All right, we're back. We've completed the top half of the soldering. We've soldered our wire on the top of the track, so that's secure. And so now we're on the bottom end, and some of the people that are working on their project have legs. I am one that does not, which makes it a little bit easier for us to get to, but everything's the same. So what we're going to first do is, this is our bus wire. We've connected it here. It's been tinned, but on the other end, it has not. We had to run the wire and make sure that it wasn't too long. We cut off, and then we stripped off the plastic, and now we're going to tin. So Kevin, go ahead from here.
Okay, well, tinning is a pretty simple process. You just got to heat the wire up, and it helps if you've got it stabilized, which this one is not overly stabilized, but you get a little solder on your soldering iron to help with the heat transfer. Then as you heat your wire up, you just work it out to the tip. And it's as simple as that. It allows you to bundle all those wires, individual stranded wires together, and again, you won't have the issues with shorting out someplace else.
So,
and believe me, I've had that happen.
So I know you said that this was not stable, and if we undo the black wire to tin it as well, how would you make it more stable?
Well,
by using
a clip of some form.
A clip, okay.
Just to hold it in place.
Gotcha.
Otherwise, you've got one hand holding solder, you got one hand holding the soldering iron, you got a wire flapping in the breeze there. You got to kind of figure out how to get it all together. So here's the other wire, and I will twist them together to make sure that I don't have any extra wires or miscellaneous wires hanging out there. Where can I get somebody to, somebody want to do this?
I mean, I'll do it if no one else wants to.
I can do it.
Go ahead.
Okay.
Do you want me to hold the wire?
Here's the solder.
All right.
Here's the soldering iron.
Now go ahead.
Yep, you got it. That's it.
Oh, nicely done.
We need your help. We need your strength and youthfulness and vitality and Boy Scout expertise.
There you go.
All right.
That'll work.
Yeah, just set
Very
that
nice.
down.
Here's the holder.
Okay.
So now, we need to put these back.
So, yeah, black on the bottom.
Okay, now because we're going to be soldering in here, we need to use this tool. And it has the gauges of wire marked on it here. So you can see what you need to do. And this is, what is that, about 14 gauge wire?
I believe so. Yep.
See, it has one handle that, or one side that grabs the wire, and as you squeeze, it separates. Now my suggestion is when you go to another one, rather than going right here, space one of them here, one of them over here.
Oh.
That way, in the future, you won't, if you're using electrical tape, you won't have to worry about them shorting out. As most people leave their setup there for a year, 10 years, maybe more, and the electrical tape, and it tends to unravel itself. So that's my particular preference. Then we will need to tin this wire.
I'll tell you what, I need 2 volunteers. Well, I have 2 volunteers.
Okay, I have a area there tinned. And I'll take this. This is really much longer than we need, but the stripped portion of it here. And I'll wrap it around this point. And I'm done.
Excellent. Okay, so we've talked about getting the rails nice and shiny, getting the oxidation off so that the solder will adhere better to the rail and the joints. We've cut wire, we've split the wire, we've taken all that stuff out. Again, you can see the Euro or the Phoenix connectors are been put on, and how do you attach those. There was a question, Bill, you had a question about
Suitcase connectors.
and can you talk a little about what they are and why maybe you don't want to use them or why you would use them?
Well, suitcase connectors will take 2 wires, and what it does is it'll have a piece of metal in it, and you slide the wire in there, and then you'll close down on it, and and it goes over to another place. So your wire that is going through your main connector would be there, and then another connector where you're looking for that signal or that voltage would go to the other one. And I have had problems with them in the past where in my career I worked around electricity a lot, and I had somebody use those, and I had it was an X-ray machine, and the control desk, which had about 60 connections to the outside world, he used those on there. And I had to go through and take them all out and redo the whole thing. It took me 3 days, and it cost the customer a lot of money to have me do that. Yes, they're faster, but yes, they're going to cause you problems in the future.
So in the event, probably if you could not solder, or if you're not skilled enough or don't want to even attempt that, you can use what they call this suitcase connector. You put the wires in and clamp it,
Right.
But you don't know 100% if when you clamp that, it's got a great connection or not.
And
whereas with soldering, you know if it's on, it's connected.
True. The suitcase connector will work for a while. How long depends upon the quality of the suitcase connector, I guess. My experience with them has been that I can get about 1.5 years out of them, and then I have to go in and open them up and reseat wires, and if you have a large layout and you have 40 or 50 of these things in here, now you got to find the one that's bad. And once you clamp them closed, they're a little difficult to pop apart, to open up. So it will try your patience tremendously. Let me make one more. I haven't done it here. I probably should do it. I would take this off, take a piece of heat shrink compound or tubing, and figure out how much I need there, cut it off, put that on there to insulate it. You put it on there, then you take, since I don't have a match or a cigarette lighter, I would take my soldering iron and not use the tip, but the body of it here, and rub it across that, and that'll shrink that tubing down so it grips and keeps from moving.
If you don't have the coating, electrical tape, if you
well, heat shrink tubing you can pick up at the hardware store.
but if you don't have that, you could use what you were saying, electrical tape. But
Yes.
there again, after that
A period of time.
will degrade and it could come apart. So that would be your alternative. So I
Right.
think that would be a great idea.
For more information about the Apple Valley Model Railroad Club, visit their website at avmrc.com.